How's the guys? Bonzet here. Once again, thank you to Liberty to make the show possible. You guys at home, give the Tenfold Education app a follow. And once again, thank you for all the questions coming in. Now I'll be revising. That's what we're going to do. We need to get you ready for this prelim exam and for the final exam. Thank you so much for the questions that came in on Facebook. Don't forget to post the questions, send a photo, and we can discuss the question live here in the studio. Okay, so let's get going. So last week we looked at map work a little bit, but today we're going to focus on revision. And revision is quite important because, you know, I always tend to tell my learners, the interesting thing about it, the questions are different, but the answers are very much the same. They might use a different case study. They might use a different map, might use a different figure, photo that you need to interpret. Okay, so pay attention. My best advice for you is go and have a look at old question papers, best preparation you can do for your exams. Okay, so our first question that we have here is a question, and the question is from KG. Now, thank you very much for this question, and this question is regarding climate. And when we look at climate, and currently we experience quite a lot of this weather phenomena currently in South Africa. And this is a mid-latitude cyclone. Okay. Now pay attention to the question. Study the plan view and the cross-section through a mid-latitude cyclone. Now first of all, let's just identify which one is the plan view. This one is the plan view. Okay. It's almost like a synoptic view. It's from above. Okay. And this is a cross-sectional point of view when you're standing from the side. Okay. But before I'm going to delve into the questions, just let's have a look at a mid-latitude cyclone. Now, grade 12s, like I've always said, the name kind of gives it away. A mid-latitude cyclone. Okay. Now, first of all, let's just decipher this. Mid-latitudes, where does the formation takes place? Usually between 35 up to 60 degrees north and south of the equator. And what do we know about cyclones? It's a low pressure system, and because we live in the southern hemisphere, the circulation of air is always going to be clockwise. Okay. Now, what makes a mid-latitude cyclone so distinctive? Now, please remember, there's still some confusion between tropical cyclones and mid-latitude cyclones. Always remember, once you see fronts, okay, once you see fronts are present, you immediately know it's a mid-latitude cyclone. Now, when I talk about fronts, I'm even going to use the color pens to show you. B represents the cold front. Okay, so if you look at it on cross-sectional point of view, there you can see there's B. Okay, and C represents the warm front. It's this area over there. Now, before I'm going to continue, let's just quickly define what is a front. A front is the leading edge. A front separates two different masses of air. So when we see a front, on the one side there's going to be two different masses of air. And when we talk about two different masses of air, we're talking mainly about the temperature. Okay. So what does a front do? It separates two masses of air. Let's just get that concept correct. So let's just write it down there. A front, it separates two masses of air. Okay. Now, when we look at the cold front, unfortunately, I can't use it because my back screen is blue, so I'm just going to represent the cold front in black. Okay. Sharp triangles. Now, what can we say about the cold front? If the cold front is over there, the cold front is the leading edge of cold air. Okay, and same goes for a warm front. The warm front is the leading edge of warm air. Now, let's just quickly go and have a look at our plan view. First of all, let's just, by looking at this plan view, we can make a couple of notes on it. So that's the cold front situated over there. So I've just mentioned a front separates two masses of air. So the cold front is the leading edge of cold air. So the air behind the cold front is going to be cold. Okay. They're actually given you the warm sector. As you can see, the warm front is the leading edge of warm air. So between the cold front and the warm front, it's warm air. Okay. What's happening in front of the warm front? Keep in mind, it's also going to be cold air. So this whole section that you see over here is cold air. Now, I try to explain this to my learners. What's basically happening over here? So it's a disturbance that's taking place between the major cells. It's usually between the between the easterlies and the westerlies taking place. Polar easterlies and the westerlies. It's a disturbance taking place, and because in the southern hemisphere you've got a clockwise circulation taking place. So two distinct fronts has formed. Now I always tell my learners what basically happened over here. The cold front, it's like cowboy and crooks. It's like cops and robbers. The cold front tries to catch up with the warm front. That's what's basically happening over here. Now I'm not saying that the warm front is stationary, but it moves much slower than the cold front. So eventually what's going to happen, I quickly want to just draw a diagram how it develops. If you look, especially from a South African point of view, because it's currently happening, we're expecting snow over the weekend from Friday on over Lesotho, it's because of a cold front. So let's say, for instance, that's South Africa. There's Joburg, there's Durban, there's Cape Town. Now remember, these mid-latitude cyclones is vitally important for South Africa because it brings much needed rain. There's the cold front. Okay, that's the one that we usually experience. Okay, further down south, attached to it is the warm front. We don't see it because it's too far down south. How does this system move? Remember, the circulation of air inside it is a low pressure. Okay, clockwise circulation. Now what I mean is, I'm not saying this warm front over here is much more stationary. It does move, but not as much as the cold front. Okay, and the whole system moves from west to east. Why west to east? Because it moves in the westerly wind belt. Okay, now remember, from my plan view, unfortunately I can't use blue. The air behind the cold front is cold. This whole sector, this is the warm front. It's the leading edge of warm air. This whole sector over here is warm. And once again, this sector over here is cold. The air in front of the warm front as well. Okay. Now, as you can see, this is the whole system. It moves from west to east. Now, if we move over to our cross-sectional point of view, the little cartoon panda, the direction of this movement is what? It moves from west to east. Okay. So what basically is happening over here? This cold front is moving, trying to catch up with this warm front. Now, pay attention to the information that's given to us over here. They mention heavy rain. Okay. Warm air rising. Because why is there warm air rising? Because we know this sector over here, sorry, I just want to use a red pen to make it more simpler. This section over here is the warm sector. Now, as you can see, heavy rain is being experienced over here. We experience warm rising air. Now, the simple reason for it is because we can also see the cumulonimbus clouds. Okay, cumulonimbus clouds form where the cold front forces the warm air to rise. As you can see, the warm air is being forced to rise. Pay attention to the pressure gradient. You can see that there's a very steep gradient from this cold front because this process is not gentle, okay? The cold front is moving, approaching, moving fast, okay? And as it forces the warm air in this sector on our map, if you look at this sector, what does it do? It forces this warm air to rise, okay? We've learned about this. Now, what happens with the warm air? It cools, condenses, clouds, and definitely rain. So there's a very steep pressure gradient. This is not a gentle process, okay? Because the air is being forced to rise. Eventually what will lead? It will lead to cumulonimbus clouds and will lead to rain. Now, as you can see, they've mentioned it over here, heavy rain. But where the warm front is, we experience light rain. And I want to add it over here. We experience nimbus stratus clouds over here. It's also a rain clouds. Now you know nimbus means rain. So we experience nimbus stratus clouds at the warm front side. Now what's the reason for it? Look at the pressure gradient being indicated by the cross section. You can see it's much more gentler. Okay, it's a gentle pressure gradient. Now nothing is forcing the cold air above the warm air above the cold air. Apologies. Okay. What happens? This warm air just slides over the cold air. It's not being forced because the cold air was already in front of the warm air. So we experience nimbus stratus clouds, light type of rain. But very importantly, what we're going to discuss with this question, we don't experience the warm front conditions in South Africa. Ever. Okay. Most of the time, majority of the time, only 99%, we experience the cold front conditions. Now, if you go back to our diagram that I've tried to draw with my beautiful South Africa, I do apologize for that, we only tend to see the cold front. Even if you look at the weather tonight, you will only see the cold front approaching. Okay. The warm front is too far down south. Okay. So that's what's been given to us, just to be able to explain to you what I see from the plan view or synoptic view and the cross-sectional point of view. Okay, I just want to clean this out because I might use it again to explain the questions. So vitally important, remember grade 12s, when we look at our plan view, immediately when you see a cold front and a warm front, immediately you should know it's a mid-latitude cyclone. Okay, there needs to be two fronts present. Clockwise circulation because it's a low pressure system in the southern hemisphere. Right, let's look at the questions. So, in which general direction does the cyclone move in the southern hemisphere? Now, I've already answered that question to you, and the correct answer, it's moving from west to east in the westerly wind belt, and the circulation of air in the low pressure system is clockwise. Okay. So that answers that question. Moves west to east. Okay. Now, give two pieces of evidence to support the statement that the cyclone is in its mature stage. Okay, excellent question. Now, we have quite a few stages when we look at mid-latitude cyclones, and I'm just going to continue on the bottom. Now, when we look at the initial stage, I've mentioned it a little bit earlier, right? You've got your polar front, and then you've got your, keep in mind, your very cold polar easterlies. Okay, moving in the one direction. And then in the other direction, the polar front separates the westerlies from the polar easterlies. That's the initial stage. So we refer to it as a disturbance taking place. Okay. When we talk about disturbances, it might be friction taking place on the side of the polar easterlies, even on the westerlies. And it creates a kink in this polar front. And that sets the whole cyclone in a rotating order. And because it's in the southern hemisphere, it's a low pressure cell. Now, if we look at our question, they really told us that this images that's been given to us is in the mature stage. The simple reason why, because two distinct fronts has already developed. There's the cold front and our warm front. Two distinct fronts has developed. As you can see, there's the warm front, clearly distinctive warm front, and you have your cold front. Now, with the initial stage, like I've shown you, there's no fronts, okay? It's just the polar front that's separating the air moving in opposite directions. But with the mature stage, we see two distinct fronts, the cold front and the warm front. And that's easily also another way to remember that this is a mid-latitude cyclone. Okay, so two distinct fronts has formed. Now, our next question, 1.2.3, why does the warm front C have very little influence on the weather of South Africa? Once again, I've shown you. Now, the latitudinal position through South Africa, sorry, I can't use blue because you struggle to see it, is 30 degrees latitude. Okay, as you can see, we only experience the cold front, this section over here. The warm front section just happens too far down south. That happens roughly at 45 degrees latitude, okay? So it's only the cold front conditions that we experience, especially the Western Cape, okay? Pay attention to the news bulletins later today. There's a massive cold front approaching. We refer to the cold front, but it's actually a mid-latitude cyclone, but we only refer to it as the cold front because it's only the cold front that has an impact on us, okay? But pay attention. Huge amount of snowfall that we might experience in the next couple of days. That's because of this mid-latitude cyclone, and it's because of that cold front. Okay. Let's have a look at our questions. Now, why does the front C have very little influence on the weather of South Africa? Like I've mentioned, the warm front, it's too far down south. The latitudinal position is too far down south. Now, question 1.2.4. I'm very excited for this question. KG, thank you so much, because they tend to ask this question every single year. Now, what I like about this question, they asked about both. They asked about a warm front occlusion, and they've asked about a cold front occlusion. Absolutely beautiful. So that gives me opportunity to explain both to you. Okay. Now, what do we know about occlusion? Occlusion is basically the last stage. It's where the cold front eventually caught up with the warm front. Like I've mentioned to you, it's like cops and robbers. The cops are the cold front and the robbers are the warm front. The cops tries to catch the robbers, and eventually it does. It pans out beautifully. Okay, so the question states, in a paragraph of approximately 8 lines, explain the process of occlusion and associated weather conditions of a mid-latitude cyclone. Now, I'm going to draw it down on the bottom of the page. Now, after the mature stage, we have the occluded stage. It's when the cold front caught up. Now, keep in mind, I'm going to use the color green for the cold front. I'm still going to use the color red for the warm front. So eventually, the cold front has caught up with the warm front. Okay. So, in theory, there's no more warm sector left. It's been reduced because this cold front has caught up with the warm front. Now, when that happens, we are dealing with two different types of occlusions, a warm front occlusion and a cold front occlusion. Okay, and I'm going to show you this by drawing a diagram. It's the easiest way to do an explanation and for you at home to understand this absolutely 100%. Now, and I'm going to use a cross-sectional point of view. Now, this is the surface. Now, eventually when the cold front, remember I'm using my green pen as the cold front. There's the cold front. I'm just going to, like it's been shown on a synoptic view. Okay, little triangles. It's just blue in color. Now, when the cold front caught up with the warm front, they will be occluded as such. Now, with a cold front occlusion, okay, I'm going to explain the cold front occlusion first. With a cold front occlusion, I'm going to make it very simple. The cold front attaches itself to the surface. Now that's exactly what happened there. Now, the cold front attaches itself to the surface. Now think of this of a cross-sectional point of view, the same as this. So just to explain to you on this diagram that's been given to us, basically with the occlusion stage, this cold front is not there anymore, where it's situated over there. It's right against the warm front. I keep on bloody using the red pen. The colors make it so easy to explain it beautifully. Okay, so that's where the occlusion stage is. So the cold front is caught up with the warm front, like I've mentioned. The cold front is now right there, close to the warm front. It's caught up with it. Now, a cold front occlusion is when it eventually caught up with the warm front. Let's just get back to my diagram. So the cold front is caught up with the warm front. Now, basically what happens, a cold front occlusion is when the cold front attaches itself to the surface and the warm front attaches itself to the cold front as such. Okay. Now, the reason being for it, and I'm just going to fill it in here. The air behind the cold front is colder than the air in front of the warm front. Now remember, when the occlusion took place, all the warm air has been displaced. So what do we find? We only find cold air on the bottom of the surface. Right, this cold front has come in. It has forced all the warm air to rise. Right, it has caught up with the warm front. So there's no more warm air on the surface. All of the air has been lifted. Okay. So we're only stuck with cold air. But when we experience a cold front occlusion, the air behind the cold front is colder than the air in front of the warm front. Let's have a look at the diagram. As you can see, a cold front occlusion is when the cold front attaches itself to the surface. The air behind the cold front is colder than the air in front of the warm front. As you can see, all the warm air has been displaced. It's up. Okay. Now, the air behind the cold front is colder than the air in front of the warm front. So basically what happens, think of this scenario. When you jump into the swimming pool, where do you find the coldest water? To the surface. Okay. Now, if I can just use the explanation over here. If we need to add 2 buckets of water, icy cold water and mellow water, okay, room temperature water. What's going to happen, but I'm talking huge amounts, what's going to happen with the coldest water? It's going to sit closest to the surface, okay, because it's heavier, it's denser. Right. Now, with a cold front occlusion, with a warm front occlusion, it's completely just the opposite. Now, with a warm front occlusion, the warm front attaches itself to the surface. There's the surface. There's the warm front. Okay. And the cold front attaches itself, I can't use, let me use yellow, attaches itself to the warm front. Now, once again, repeating myself over here, it's an occlusion stage. That cold front is caught up with the warm front, displaced all of the warm air. Okay. Now, with a warm front occlusion, the warm front attaches itself to the surface, as you can see on my diagram. The reason for it, because the air in front of the warm front as you can see, I'm saying it's very cold. It's colder than the air behind the cold front. All the warm air has been displaced. Now, as you can see, with the warm front occlusion, the warm front attaches itself to the surface. Reason why is because the air in front of the warm front is colder than the air behind the cold front. Now, if we look at this diagram, I'm going to give you two examples, exactly the same that I've just done on the bottom, and explain it quickly on this diagram over here. Oops, let's get my eraser. So, we established this cold front is moved from west to east. It has caught up with the warm front. So here's the cold front. Okay. Now, we experience a cold front occlusion. What will the warm front do? The cold front will be attached to the surface. The warm front attached to the cold front. What's the reason for it? Because the air behind the cold front is very cold and is colder than the air in front of the warm front. Remember, all the warm air has been displaced. That's a scenario with a cold front occlusion. Okay, warm front occlusion. Let's have a look. So what happens? The warm front attaches itself to the surface. Okay, cold front is caught up. It attaches to the warm front. Okay, reason for it, because the air in front of the warm front is very cold. It's colder than the air behind the cold front. And all the warm air has been displaced. Okay, like I explained to you, with the swimming pool, you're going to find the coldest air closest to the surface. Okay, always closest to the surface, because it's heavier, because it's denser. Okay, hopefully that answers your questions. Remember, great souls, if you struggle to explain this question, try and illustrate it with a diagram. No problem. Obviously, labeling it as well. Okay, so let's just quickly have a look at the next question. Now, question 1.2.5. In a paragraph of approximately 8 lines, explain the influence of mid-latitude cyclones in the Western Cape. Now, grade 12s always think you're a geography student. Keep this in mind. Economic, social, environmental consequences. Okay. Now, when we look at mid-latitude cyclones, it's not always just bad. Now, for instance, if we look at tropical cyclones, I'm going to be honest with you, 99.9% about tropical cyclones, nothing is good about tropical cyclones because it's much smaller in diameter, but we're talking about wind speeds of 250 kilometers per hour. It creates so much damage, you know, high wind speeds, storm surge, lots of rainfall over a very short period of time. So, tropical cyclones are quite nasty. But when we look at mid-latitude cyclones, not all of them are bad. Okay, we got positives and negatives. And I'm going to table them for you. But keep in mind, when we ask this question, always refer to economic, social, and environmental consequences. Now, the question states, explain the influence of mid-latitude cyclones in the Western Cape. Okay. And I'm quickly going to do it here on the bottom of the page. And what I'm going to do is, I'm going to make positive and negative influences. Okay. First of all, positive, it provides them with rainfall. Okay. Much needed. Now, if you look at the Western Cape, right, they receive their winter rainfall. These mid-latitude cyclones is the reason we experience a Mediterranean climate down there. If you look at the Western Cape, especially during summer months, it's extremely dry. Okay. Now, these mid-latitude cyclones are responsible for the winter rainfall. Now this rainfall, now if you go down to Cape Town, obviously farming. And I'm talking wine and grape farming taking place. Okay, it's the mecca for wine farming in South Africa. Okay, very important. This rainfall leads to farming. Okay, it means we can farm more. Now think of the economic consequences of mid-latitude cyclones. It means we can create employment on these farms. And with more employment opportunities, what do? We add to the GDP of the country. The GDP grow. Okay. Another reason for it, especially with the rainfall, it's important for tourism. If you look at Cape Town, it's probably one of the most beautiful places in South Africa. So it creates a tourism industry for the Western Cape province because of the amount of rainfall. It makes it beautiful if you think of Table Mountain. And if you think of the wine farms, you go to a wine farms, you go and do wine tasting, go to restaurants, etc. on these beautiful settings. Okay. So economically, it provides employment opportunities. GDP, it creates growth. The rainfall environmentally is good for deforestation, etc. It doesn't cause. Obviously, farming of wines and grapes, vitally important. It provides jobs. And with the GDP growing, what does it do? It gives infrastructure, growth to it. Oh, just my spelling correct over there. Growth, infrastructure. So it's much needed rainfall. We need it, okay? And it creates employment opportunities economically, socially. Now, socially, how can it affect us socially? Now, obviously, it creates food security. It means you have food for a daily basis, okay? So you don't need to worry about food insecurity. It means you don't need to go hungry to school, for example, okay? Negative consequences. Unfortunately, keep in mind, these storms can be hectic, okay? They can create huge amount of damage. Now, unfortunately, if we look at South Africa, we have many informal settlements, okay? Now, these structures, we discussed it before, are not built to regulations. Now, when we experience these mid-latitude cyclones, you need to keep in mind, we experience wind speeds up to 120 kilometers per hour. We experience very cold temperatures. We experience torrential rainfall over a period of a week or a couple of days. Okay, so economically, it damages infrastructure. What else? It might cause flooding. And flooding can be a disaster for the farmers. Okay, it may cause damage to the vegetation. So, great risk. Now, socially, we can also have loss of life. People might drown. People might die because of this mid-latitude cyclone. Also, we can mention loss of life, for example, damage of infrastructure, but socially, it can lead to food insecurity. Okay, reason why is because it causes damage to infrastructure. Farmers might lose their farms. It might lead to unemployment. Okay, so people can't provide for their families anymore. Now, we also experience storm surge. Now, that's the wavelength that increased on the coastline and can bring very extreme cold conditions towards the coast of the Western Cape. But that's the negatives. But I believe, if we look how far we've come, basically we can absorb these difficult situations that do take place. But it's more important for the amount of rainfall and the water that's been provided to create better opportunities. I just want to add there to negatives, it might cause deforestation and as well as soil erosion. Now, once again, grade 12s, when you look at this question, think about the positives and negatives, okay? Not all of them are always negative, okay? Cape Town, a couple of years ago, experienced massive droughts, okay? If you're currently following the news, most of the dams down in the Western Cape are almost 100% capacity. Why? Because of these mid-latitude cyclones. So in the end of the day, they're doing us a huge favor to be able to survive, to irrigate during their dry summer months.